All right, we looked at these integrals with sine and cosine with exponents, and we looked how to do it if it's odd. What happens if it's even? Then our trick doesn't work anymore that we used before, because if we substitute 1 minus cosine squared in for this, we still have the problem where we got this exponent and we don't have a way of doing that with a substitution. So if you have only even powers, what we're going to do is use our trig identities for sine squared and cosine squared. So if we got sine squared, we are going to substitute the identity that it's 1 minus cosine of 2x over 2, or 1/2 of that. If it's cosine squared, we're going to substitute 1/2 plus, or 1/2 times 1 plus cosine 2x in there. So those are, that's kind of the identity that we're using here. All right, so let's go back and look at that one, see if we can solve it. So sine squared, what we know that's equal to then is that we are going to, or that's equivalent to 1/2 times 1 minus cosine 2x. Okay, that half is just a constant, so if we want to pull it out, we can. Now let's try to figure out what the antiderivative of this remaining stuff is. For the cosine 2x part, if you need to, you could do a substitution on that where you substitute 2x in place of that. Or if you can just do that one in your head now after doing a lot of these chain rule derivatives, you can do that too. But what this should end up being for the antiderivative then is antiderivative 1 is just x. Antiderivative of cosine would be sine 2x. But remember, you got to kind of, unless you're going to do substitution up here, you got to kind of think what else would need to be in front of that. We'd need a 1/2, because when we do this derivative, there's going to be that extra 2 and we do chain rule. We need that to cancel out because there's no numbers in front of this. So that's why that half goes in there. Otherwise, if you can't do that in your head, then like I said, use substitution. All right, so now we want to evaluate that at both pi and 0. If we put pi in there, we are going to get pi minus 1/2 times sine of 2 pi. Well, sine of 2 pi is same as sine of 0, which is 0. So that's just 0. Minus, if we put 0 in there, that's 0. Sine of 2 times 0 is still 0. Sine of 0 is 0. So it looks like the answer on this one's going to come out to be just pi over 2. So that would be the answer for that one. All right, let's try another one here. Find the integral of sine to the 4th. Another one where we only have an even one. There's no odd one. So again, we have to do one of those substitutions for sine squared. And we know sine squared is equal to 1/2 times 1 minus cosine of 2x. However, here we have sine to the 4th, which means we have all of this. Then we got like 2 of these. It's like sine squared times another sine squared, or we could also think of that as sine squared squared. And so we're going to have 2 of these. So we have to take this and square all that for this integral. So doing that, what that's going to now end up being is we have 1/2 squared. 1/2 times 1/2 is going to be 1/4. And then we have all this 1 minus cosine 2x being squared. And that means we're going to have basically 2 of these being multiplied to each other, which we're going to have to figure out here to do our integral. So I'm going to pull the 1/4 out. Now let's distribute and see what we get here. 1 times 1 is 1. We're going to have a 1 minus times cosine 2x and another 1 times negative cosine 2x, so that's going to be minus 2 cosine 2x. And then if we multiply cosine 2x times another cosine 2x, it's going to be positive because it's two negatives. And that would end up being cosine squared of 2x. Okay, so now we got to look at each term here and figure out what we're going to get for each of them. This one we're going to be fine doing the antiderivative of. This one we should be able to take the antiderivative of. Ooh, here's a problem one though. That's another squared one here. So what we're going to have to do a second time here is substitute one of our identities in for that. So this time we're going to use that cosine squared is equal to this one right here and do that for cosine squared. So we got to make another substitution here. That's still 1, this is still this. But we'll use our identity here and substitute in for cosine squared that's 1, that's going to be 1/2 times the value of whatever you have here, cosine of 1 plus cosine 2x. The difference with this one though, it's 1/2 times 1 plus it's cosine square, or cosine of, I'm going to go back to here, cosine of 2x. But in this one, we're already dealing with a 2x. So if we already have a 2x here and we put 2x in here, now it's going to be 2 times 2x. So this will turn into cosine squared of 4x because it was already a 2x instead of an x. All right. Now, this squared shouldn't be here. That wasn't part of the identity. All right, now to finish this, we want to go through and find antiderivatives. I'm going to do one last thing here, though. We do have that that 1/2 right here. Let's distribute that to both things here before we find the antiderivative. That's just going to make it a little bit easier. All right, so now all of these we should be able to do at this point. And if we wanted, we could even simplify a little bit further that 1/2 and the 1 we could put together as well. Those are both constants. I'm going to do that here, so that would turn into 1 plus 1/2 is 3/2 here. Okay, so let's find that antiderivative. We still got our 1/4 out here. Antiderivative of the first one's just 3/2 x. Next one, antiderivative of cosine is going to be sine of 2x. But remember, it's going to need like another reciprocal out here of 1/2 with our 2 we already got there. So that would just cancel out and just be minus sine of 2x. Because if we took derivative of this right here, we should end up with what's right above it. Okay. Next term is this one over here. So we got, what's the antiderivative of that? Well, we got this 1/2. Antiderivative of cosine is again sine of 4x. But if we took derivative of that, we got to do chain rule there to end up being this extra 1/4 here when we did that. And then this one is not a definite one, so it could have a constant on out here as well. So last thing now, we want to go through and see if we can simplify or distribute out that 1/4 here, and we should get the final answer. So we'd have 1/4 times 3/2 would be 3/8 x minus 1/4 sine 2x. Here we got these two multiplied together is 1/8 times 1/4 would be 1/32 sine of 4x. And that right there would be the antiderivative of this one. All right, last one. Why don't you give this one a go? One thing you're probably going to have to do first here, though, that we'll do together is this is 1 plus cosine theta all squared. So you are going to have to do a little algebra up front here and distribute this out. Think of it as 1 plus cosine theta times another 1 plus cosine theta. And we're going to have to distribute that out first. So we get 1 plus cosine theta times another cosine, or plus another cosine theta would be 2 cosine theta. And then cosine times cosine is cosine squared. So this one had some simplifying up front. Now see if you can pause the video and try the rest. All right, hopefully you've had a chance to try this one. This one, antiderivative, we should be okay with. This one we should be okay with. Here's the problem one. That's where you had to make the substitution. So that substitution should turn into 1/2 times 1 plus cosine 2 theta d theta. Before we do that antiderivative, let's distribute that kind of like we did in the last problem. So we got 1/2 plus 1/2 cosine 2 theta. We do, before we do antiderivative here, we can put some of these like ones together if we want. These two would be like terms, so we could put those together. That'd be 3/2. And also, oh, I guess those other two are not like terms because this is only theta, and that's 2 theta. So now let's find our antiderivative. All right, so the first one here, that's just 3/2 theta. The next one, that's going to be antiderivative cosine is sine, so that's 2 sine theta. The next one, antiderivative cosine 2 theta is sine 2 theta, but you got to think opposite of chain rule now. There would be an extra 1/2 out here. Plus there was in addition to, there was that other 1/2 out there. So if you simplify that 1/2 times 1/2, we get 1/4. And that would be the final answer that we are looking for on this one. So if you got that, great job there.